Hello friends, welcome you all. Today's topic is regular expressions and you can call them as RE in short. So now you friends you can see here first we will discuss about what are regular expression and what how to define regular expression. Regular expressions are the way to represent set of strings, and as set of strings is also known as language, so regular expression is the way to represent a language. And as regular expressions are there, so they represent regular languages. So they represent regular languages. So now regular languages can be implemented by DFA, NFA, NFA with epsilon move. So all these structures we have already discussed in previous lectures. So these are basically the way to implement regular languages. Now there are how to write regular expressions. So you can say I will take one example here, and it is like 0 plus 1 whole asterisk and 0 1. 0 plus 1 whole asterisk 0 1. So this you can consider as one regular expression, and as you can see only two symbols are there in this regular expression, 0 and 1, and some operators we have used here. So this like this you can represent any language, and this regular expression is basically representing all binary strings ending with 0 1, ending with 0 1. So this is the regular expression for representing all binary strings ending with 0 1. So I hope friends it would be very much clear, and I will one by one we will discuss the operators used in regular expression, and then we will also discuss the algebraic law related to regular expressions. So now we will discuss what are the different operators that we can use within regular expressions. So friends, these are the operators that we use in regular expressions. So you can see here we are using two types of plus operator. One is binary and one is unary. So I will tell you the difference between these two, and how to use these all operators. So first we will discuss with binary plus, and this binary plus is used to provide choice between different symbols in the regular expression, between symbols in the regular expression. Like in a previous example you can see 0 1 two symbols were there, and if I apply plus operator between these two, so it becomes 0 plus 1. That means either you can select 0 or you can select 1, but not both. But not both. So any one of them you can select. So this binary plus provides the choice between the two symbols. Choice between the two symbols. So we can write it like this: 0 plus 1 means either you can select 0 or you can select 1. So now, if it is regular expression, it must be representing one set of strings. So what is this set? So we can see here only two symbols are there connected with plus operator. So either you can select 0, so 0 string you can create with this, or you can select 1, so another string that you can create with this is 1. So only these two strings are there in this set. So this regular expression is representing this particular set. So the language of this set is having only two strings. This regular expression is representing finite set. So now we will take this dot operator. This dot operator. So as we used binary plus to represent choice between two symbols, so this dot we use to connect two symbols like 0.1. 0.1, that means the string must have 0 and 1 both together. 0.1 means 0 and 1 both will come together. So the if we consider this as one regular expression, so this set would be having only one string, which is 0 and 1, 0, 1. This set would be having only one string, which is 0, 1. So only this string you can create with this regular expression. So this is how you can use dot operator there. Now, if we consider any string with zero length, so you can represent it with epsilon, and this symbol is known as epsilon. This symbol is known as epsilon. So this represents a string with zero length, a string with zero length, and this means no symbols are there, empty string. Now, one more thing is there. If no strings are there in the any language, then this will be represented by phi, which is null set. That means there is no strings in any in particular language. So, phi and epsilon are two different things. Phi means no string at all in the language. Epsilon means there is one string with zero length. There is one string with zero length. So these two are terms also we use in a regular expression, so that we can use there. Now friends, in some cases we need to repeat any symbol many times. So in that case, you can write like this: U 0 0 0 0. Now these are four zeros consecutively. Now if I want to use infinite length of such a string, then I can represent it with one one regular expression, which is like asterisk, zero asterisk, zero asterisk. Asterisk represents clean closure. Asterisk represents clean closure of zero. Clean closure of zero. That means zero is a symbol where you can have any number of occurrences of this zero. So this particular set will represent, this regular expression will represent one set which is having C. That in this regular expression, according to this regular expression, there may be any number of occurrences of zeros. That means even zero occurrences of zero. So this would be epsilon. One occurrence of zero. So this would be zero. Two occurrences of zero. So 0 0. Three occurrences of 0 0. So this would be three zeros. And like this, you can have any number of zeros simultaneously. So this regular expression is representing this complete set. And remember, my friends, these clean closure are used to represent infinite set. Clean closure are used to represent infinite set. You can see this was finite set only with the two strings. This was finite set only with one string. This clean closure is representing infinite set with length 0 from 0 to any positive numbers. So this is called clean closure, and this is how you can use asterisk here. Similarly, if we use binary plus, if we use if we use unary plus, so now we will use plus. So as clean closure is there, similarly one more closure is positive closure. One more closure is positive. This is clean closure and this is positive closure. Positive closure. Now positive closure means it is also representing infinite set. It is also representing infinite set. Now which set it is representing? So in positive closure there must be one occurrence So in case of positive closure, there must be at least one occurrence of the symbol. So as we are having positive closure of 0, so there must be at least one occurrence of 0, then it can have any number of zeros simultaneously. So it cannot have zero occurrence of 0. That means epsilon will not be there in this set. So 0, 0, 0, then 0, 0, 0, then 0, 0, 0, 0, then any number of zeros you can write, and this is again an infinite set. But the difference between positive closure and clean closure is that clean closure also includes epsilon, but positive closure doesn't include epsilon. So these four operators we use in regular expressions. So I hope friends it would be very much clear. Now I will tell you how to use these operators to create some regular expressions. So now friends, we will take some example of regular expressions, and first I will tell you how to create regular expression for given set of strings. So now friends, I will take some example of regular expression, and suppose one symbol is there a, one symbol is there a, and I can use it with asterisk. So A asterisk, this is clean closure of A. This is clean closure of A. So it represents basically epsilon A, then AA, then AAA, then any number of A's simultaneously, right? So this is representing one infinite set. And in the same way, if I write here A plus B whole asterisk, then what kind of set it would be? What kind of set it would be? So you can see, my friend. So place A plus B in place of A. In like in this set, if you place A plus B instead of A, so what kind of set you can have here? Epsilon first, then it would be A plus B, then it would be A plus B, A plus B, then it would be A plus B, A plus B, A plus B, like this, and you can have any number of occurrences of this A plus B. So now, as I told you in earlier, like this plus binary plus provides choice between two symbols, provides choice between two symbols. So here we can use either A or B. Any symbol we can use anytime. So now this set would become, see, epsilon will be always be there. Then for this we have two choices. So first we are selecting A, so it will create A. Then second time we can select B, so it will also create B. Now again, we have 2A plus B here. So for first A plus B, I am selecting A, and for second, I am again selecting A. So it will make AA one string. Then next time I will select A in first and B in second. So it will create one more string AB. Then in next time I will select B in first and A in second, so it will create one more string BA, and one more time if I create a string using this, so both the times I can select B, so it will create BB. Now, no more strings can be created from this particular combination. So that means now we can create these strings. Now, similarly, we can move to any number of A and B. Now, remember here, with one occurrence of A plus B, we can create two strings of length 1, A and B. With two occurrences of A and A plus B, we can create four strings of length 2. That means 2 to the power 1 number of strings for one occurrence of A plus B, and 2 to the power 2 number of strings for two occurrences of A plus B. That means all possible combination for these two we are creating. All possible combination for these two we are creating. So in the same way, if we have three occurrences of A plus B, so we can create all possible combination of strings with length 3. So that means this particular regular expression will create all combination of A and B. All combination of A and B. That means this is universal set. This is representing universal set for any combination of A and B. So I hope friend it would be very much clear to all of you. It would be very much clear to all of you. Now if I write A plus B plus, that means I'm creating positive closure of A and B, A plus B. Positive closure of A plus B. So as you know friends, in positive closure, there is no epsilon. In positive closure, there is no epsilon. So minus, if we remove this epsilon from this set, it will remain have all possible combination of A and B, excluding epsilon. So this set would be like A, comma B, comma AA, comma AB, comma BA, comma BB. Like this, you can use any combination of A and B. So this particular set is representing again one infinite set having all possible combination of A and B excluding epsilon. This set was including epsilon, but this set is not including epsilon. So this is the difference between these two. So I hope friend it would be very much clear to all of you. I will take now for some more examples. So now friends, we will see some more example of regular expressions. So I'm writing here A plus epsilon. A plus epsilon. So this plus is unary plus and this plus is binary plus operator. So now you can see we have two choices, either epsilon or any member of this set. So what language it will be representing or what set it would be representing. So obviously as we have choice of epsilon here, so we can create epsilon with this set, with this regular expression. Yes, we can create. Now with this regular expression, a positive closure of A, we can create any number of A's, any number of A's starting from 1. So we can create 1A, then 2A, then 3A, then any number of A's. So now you can see, my friend, which set it is. Any number of occurrences of A, including epsilon. So this is nothing but A positive Kleene closure of A. So that means this is equal to A plus Kleene positive closure of A plus epsilon gives Kleene closure of A. Gives Kleene closure of A. So this is one more expression where we commonly use in regular expression. So I hope friend it would be very much clear to all of you. Now few more example I can take here. Now you can see A plus B whole asterisk. This is one set. As I told you, this is the universal set of A and B. and it will create all possible combination of A and B, including epsilon. Now, if I create set A plus B followed by AB, followed by AB. So this regular expression. Suppose this is regular expression A and this is regular expression B. So now we need to find out which set is bigger. This is also representing one set. This is also representing one set. Here we have regular expression A is representing all possible set of all possible combination of A and B, and regular expression B is representing set of all possible combination of A and B ending with AB, ending with AB. That means here we have applied some condition that a string of A and B must be ending with AB. So you can see, my friend, here we have selected particular type of strings of A and B. But here we have all possible strings of A and B. That means this set is bigger, this set is bigger, and this set is lesser, or you can say shorter. So number of strings in this set would always be lesser than number of strings in this set, because this is universal set of A and B. So any combination if we are applying with this along with this, so this will reduce the number of strings in the set. So this is very important observation we need to know. So you can see, my friend, in both the expressions, A plus B whole star is there. That means Kleene closure of A and A plus B is there in both the regular expression. In regular expression B, we have additional string of A and AB, additional string as AB, but this will reduce the number of strings in the set. So this set is always bigger than this set. So I hope, friend, it would be very much clear to all of you. Now, if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.